Okay, let's just state a fact. As our ML systems become the absolute crown jewels of a business, they also become massive targets for attackers. It's not just about building the most accurate model anymore, right? It's about building a fortress around it. So today, we're going to break down how to secure that entire ML pipeline. I mean, from the raw data all the way to that final prediction. Let's jump in. And believe me, this isn't an exaggeration. The stakes are just incredibly high. See, an unsecured model isn't just some tech problem for the engineers to fix. No, it's a massive business risk that can lead to absolute catastrophes. We're talking huge data leaks and a total loss of customer trust. So what exactly are we defending against here? Well, you've got the big, obvious stuff, right? Outright data breaches, someone stealing your multi-million-dollar model. But then you have the sneakier attacks. Things like prompt injection or these crazy adversarial attacks that can literally trick your AI into making awful decisions. And let me be clear, every single one of these is a real and present danger. Okay, so if we're going to build a proper defense, we first have to understand the territory. So let's map out this MLOps battlefield and pinpoint exactly where the vulnerabilities are hiding. All right, so here's the standard machine learning pipeline. You know, it looks like a nice, clean, linear process, doesn't it? But here's the scary part. There is a security risk at every single one of these stages. A weakness way back in your data collection can be just as devastating as a vulnerability in your deployed API at the very end. Now, this is what I find so powerful. Look at how it maps specific threats to each stage. Take the data stage, for instance. An attacker can poison your data at the very beginning, and that silently corrupts your entire model downstream. Or during training, bam, your IP can be stolen right off your servers. And of course, once you deploy, that API layer is open to all the classic web attacks like DDoS. This just proves it, right? Security can't be an afterthought. It has to be woven into the fabric of the entire process, right from the very start. All right, so we've mapped the terrain, we've identified the enemy's tactics. Now, it's time to build our digital fortress. This section is all about the specific, actionable, defensive strategies you need to fortify that pipeline. But hang on, before we get into specific tools, we have to get our mindset right. These are the foundational principles, the philosophy behind it all. Zero trust, that means you assume nothing is safe. You verify everything, always. Least privilege, simple. You only grant the absolute bare minimum permissions needed for a job, and nothing more. And defense in depth. This one's my favorite. Think of it like a medieval castle. You don't just have one wall. You've got a moat, an outer wall, an inner wall, guards. The idea is, if one layer fails, another one is right there to stop the attack. And this quote, man, it just hits the nail on the head. Your model's only as good, only as trustworthy as the data it's trained on. If that data is compromised or insecure right from the start, then everything you build on top of it is just built on sand. It's fundamentally flawed. Security has to begin right here. So how do we protect that all-important foundational data? Well, here are the must-dos. First, encrypted everywhere. I mean everywhere, when it's just sitting there in your database and when it's moving across the network. Next, you mask or anonymize any PII, any personally identifiable information. Why? Because you can't leak what you don't have in clear text. Then you use a private network, a VPC, to basically build a wall around your data, separating it from the public internet. And finally, you lock down who can even touch it with strict access policies, that's IAM, and you log everything, so you always have an audit trail. Okay, the training phase. This is where your secret sauce is created, right? Which makes it a super high-value target. We're defending against everything here, from malicious packages trying to hijack your expensive GPUs for crypto mining to just straight-up theft of your intellectual property. So how do we fight back? We run training jobs in an isolated VPC and, this is a big one, to prevent credential leaks, we use a dedicated secrets manager like Vault or a key management service. Seriously, these aren't just nice-to-have suggestions, they are absolutely essential. So you've trained your model. Awesome. Now it's a valuable asset, and you've got to protect it. Model extraction is a really clever threat here. It's basically where an attacker just keeps poking your API with questions to try and reverse engineer your model. It's kind of like they're playing 20 questions with your AI to steal its logic. We fight that by limiting how much detail our API gives back. And to stop people from just downloading the model file, we use a combination of access management, IAM, and tough firewall rules. Again, see? Every layer counts. Now, let's talk about your CI/CD pipeline. This is the superhighway that gets your models into production. And if that highway is insecure, you're just automating your own vulnerabilities. So rule number one, and please listen to me on this one, never, ever hard code secrets like API keys or passwords in your code. Use a proper secrets manager every time. Then you enforce other good practices like signed Docker images and automatic code scanning. This stuff makes sure that only trusted, validated code ever makes it to production. Okay, now I want to zoom in on one of the most clever and frankly kind of unsettling types of attacks. This happens at the inference stage, when the model's making live predictions. We have these incredibly powerful, sophisticated models, so how on earth can they be tricked so easily? Well, the answer is both simple and shocking. It doesn't take some massive brute force attack. All it takes is a tiny, almost invisible change. And this example just illustrates it perfectly. So on the left, you've got a model, it correctly sees a panda. Easy enough. But then an attacker adds this layer of what just looks like random static. It's what we call adversarial noise. And to our eyes, the image looks exactly the same. But the result? The model is now totally convinced, with high confidence, that it's looking at something else entirely. That's an adversarial attack, and it is a massive, massive challenge in ML security today. Okay, so we've gone over the principles and the tactics. Now, let's pull it all together into a practical security checklist. Think of this as your go-to battle plan. Now, this slide makes a really crucial distinction, so pay attention to this. On the left, you've got your should-haves. Good best practices like using HTTPS. But the items on the right, those are the absolute 100% non-negotiables. Things like proper API authentication and role-based access control, secrets management, encrypted models, these are not optional. If you are missing anything from that must-have column, you have a critical vulnerability that you need to fix, like yesterday. All right, let's flip this around for a second and look at the most common mistakes people make. Think of these as giant red flags. If you see any of these practices happening, you need to stop them. We've already talked a lot about hard-coding credentials, but another huge one I see all the time is people serving models directly from a Jupyter notebook in production. Look, Jupyter is fantastic for experiments and development, but for a live system with real users, it is an absolute security nightmare. So the bottom line is this: security is not optional. It can't be just another checkbox you tick at the very end of a project. It has to be a foundational requirement from day one, treated with the same importance as model accuracy or performance. And that really brings us to the final and maybe most important thought here. At the end of the day, this isn't just about technology or preventing attacks. It's about building trust. Your users, your customers, your entire business, they will only truly adopt and rely on these incredible AI systems if they believe, if they know that those systems are secure, auditable, and governed properly. The security of our models isn't just a technical detail. It is directly tied to the future of AI itself.